Welcome back, everybody. Today we're going to solve some logarithmic equations. There's a lot of examples here. You may want to just sort of skip around and watch the ones you feel are the most complicated. There are two styles, the kind where the log is there on both sides and you just cross it off. And then the other kind is on the back, which is where we're going to swoop. And so basically this is the property. It's the one-to-one property of equality. So this says that if the bases match, you can cross them off, and we just know that x equals y. So that's how the whole front is. Now also, you have to make sure that you check for extraneous solutions. You cannot take the log of a negative number or 0. So we have to go back and sort of check that to make sure that doesn't happen. So when you get negative answers or 0, you really got to pay attention to those. So right off the top, we know these match, so they're gone. So it's pretty simple. 7x minus 1 equals 5x plus 17. Getting the x on one side, add 1 to the other, and we simply get x equals 9. Now when you plug the 9 back in here, it's going to create a positive number, so we're good. Same thing happens here. It doesn't matter what kind of log it is. If it matches, it's gone. So k squared minus 4k equals k plus 14. So here we're going to subtract the k. That's okay. We're going to subtract 14. So we end up with k squared minus 5k minus 14. Of course, this has to be factored. So we get k, and then to get 7 times 2. So negative 7, positive 2. So here we get k equals 7 and negative 2. Now you got to be careful with the negative, but as you can see, if you plugged in the negative 2 right here, we'd get a positive number. If we plugged a negative 2 in here, that would be squared, so everything is positive, so we're good. To check, you don't have to do very much. You don't have to write it out or do any sort of proof that you check. Just make sure you check, because as soon as you don't, it'll be the one that doesn't work. All right, starting right here, we got some properties. So adding really means multiply. So smush this together. So log of 4 of times c plus 3, if I could talk, equals the log of 8. And now the logs, they still match, but be careful with going and getting rid of that too soon, because it's not an addition problem, it's multiplying. So 4c plus 12 equals 8. So we'll subtract the 12. We get negative 4, so c is negative 1. Now, if you plug this back right here, that's the only place where there's a letter, you get a positive number, so we're good. Lots of properties here. Log is 7. First of all, we have division. W plus 6 over 5w minus 3. On the other side, we have a power. Log base 7 of 8 to the 1/3. So this, we can get rid of these. We can leave this alone. W plus 6 over 5w minus 3. Now 8 to the 1/3, that's a 2. I'm going to put 2 over 1, and I'm going to cross multiply. So when you go this way, we get 10w minus 6. Going this way, we get just w plus 6. So we'll subtract the w. We're going to add 6. Don't let your brain tell you those cancel. That's really easy to do. And when we divide by 9, 12 over 9 is 4/3. Now, small numbers also need to be checked. And I don't think, none of these, this will be okay. And obviously that's okay, so we're good. I would just be careful with small numbers, negatives, and zeros. So again, with the properties, this side is good. This is going to be a power. So we're going to have 4p plus 3. A little shortcut now. We get rid of those logs because we're paying attention. And then this is a 1/2 power. Now 1/2 power is the square root. So 4p plus 3, we have square root of 16, that's a 4. And then to make this easier, you could take p to the 4th and multiply that power to power, so we get p squared. And so this will be 4p squared over here. Now I'm not going to move the p squared, I'm going to move this other stuff. because we're going to factor this. So 0 equals 4p squared minus 4p minus 3. So this is 2p and then 3 and 1. So outside we get 6 and 2, so we can get a negative 6 plus 2 will give us a negative 4 in the middle. So p equals negative 1/2 and p equals 3/2. Ooh, negative 1/2. In here it'll be positive, so we're good. And here obviously it'll come out, so we're good. Both of these work. So far checking the answer hasn't really mattered. That's kind of bummer. So we get a power, ooh, and another power. And division, yikes. I'm gonna go through this one a little slower. So natural log of a plus 1 squared. Over here, this is the natural log of 80 divided by 5, but then this whole thing is to the 3/2 power. You should put that in the calculator. The natural logs are gone. You have to square this. So that's a plus 1 times a plus 1. So this is a squared plus 2a plus 1. Over here from the calculator, 64. Bringing the 64 over, setting it equal to 0. And we would get a plus 9 times a minus 7. So here we get a equals negative 9 and a equals 7. Now negative 9, there's no way that works. So if you put the negative 9 right here, negative 9 plus 1 is a negative 8, and you can't have that. So we only get one answer, a equals 7. Now on the back we have slightly different directions. We're still trying to solve. Again, condense. Then we're going to rewrite it in exponential form. And again, we still have to check. Rewriting in exponential form, this is, sorry about my pencil, this is swoop. So that's what that means. We're going to swoop. So we don't have any properties to follow, so we're just going to merely take this and put this back as a logarithm. So we're going to rewrite it in exponential form. It is a logarithm, sorry. So 2 to the 7th equals 3x minus 4. That's how you get rid of the logarithm. Base all the way over, back in. So 2 to the 7th is 128. And then we'll solve this. 132 equals 3x. So it's 132 thirds. Which, when we put that back in for x, it's going to stay positive because that's a big number. Now remember, no base is base e, so swoop this out. E to the 9th equals 2a, and then divide by 2. E to the 9th is a huge number. You do need your calculator for that. We go to 3 decimal places. Doesn't say that anywhere, but we always go to 3 decimals. So when you put this in the calculator, you get 4051.542. And that large of a number, I think we're fine. Plus, there's no negatives in the problem. All right, so the first thing we're going to do with this one, before you can swoop it, it has to be by itself, so we'll add the 5. So we have log base 6 of w plus 7 to the 2nd equals 2, sorry. And now we swoop this. 6 squared equals w plus 7. So we end up with w equals 29. And again, there's really no negatives or anything in the original problem, so we're good. For number 10, we have a few more things to do before we can swoop this out. So we have to subtract the 4. So we get log base 9 of k squared plus 2k equals 1. Oop, there's a 2 there, sorry. And we'll divide everything by 2. So this whole side got divided by 2. So we have the log base 9 of this algebraic expression equals 1/2. So 9 to the 1/2 equals that. So 9 to the 1/2 is 3. And then, of course, we have to get this thing set equal to 0. So k squared plus 2k minus 3 equals 0. 3 and 1, positive 3 and a negative 1. Both of these are going to work. We get k equals 1 and negative 3. And as you can tell in the original, there's nothing negative. We're not subtracting, so everything is good. We're going to keep it there because the negative 3 will get squared. That's what I mean by there's nothing negative. So they both stay. This, of course, means we're going to multiply that adding. So we have log base 4. I'm just going to multiply them together. That's the difference of two squares. This is 4v squared minus 9 equals 2. And swoop this out. So we have 4 squared, which you could go ahead and write that 16 if you wanted to. 4v squared minus 9. So we know that's a 16. We don't have to factor this because it's just v squared. So we can set this thing equal to 0. Or set it not equal to 0. Rather, we can just move the 9 over. Divide by 4. And take the square root. So we get positive and negative 5 over 2. Now we have that negative number. If you put a negative 5 over 2 in there for v, I'm looking at this one specifically, that's going to be negative 5 plus 3. That's a negative number. So the only one that works is 5/2. Putting this one back together, natural log of 27 to the 1/3 times x minus 5 equals 4. 27 to the 1/3 is a 3. This is base e. So we get e to the 4th, I'm going to multiply this out, equals 3x minus 15. So we would add the 15 and then divide by 3. So you got to be careful when you put this into your calculator. Just to make sure you're doing it right, you should probably actually try it, see if you get this answer. So press pause and see if you get 23.199. If you're not able to get that, let me know. I'll help you with your calculator. But that's really a calculator issue. If you can't put it in the calculator, we gotta fix that because that's the only way to get the answer. So on this one, we're going to multiply. We have log base 2, and we're going to multiply n minus 3 times n plus 1. So I'm going to swoop this out, 2 to the 5th. And then when you multiply this, we get n squared minus 3n plus n minus 3. So this is 32 equals n squared minus 2n minus 3. And we got to move the 32 over. So 0 equals n squared minus 2n minus 35. So this is n minus 7 and n plus 5. So here we get n equals negative 7 and 5. And when you put a negative 7, I'm thinking right here especially, that's automatically going to be a negative number. It's over here too. It doesn't really matter. It's negative both places. Sorry, it's a negative 5. You probably knew that, and a positive 7. So when we put the negative in there, it doesn't work. So the answer is just n equals 7. Still there? Let's do this last one. Division. So we have log base 2 of c squared over 3c minus 5 equals 2. Well, 2 squared, that's 4, equals c squared over 3c minus 5. Now we can cross multiply. C squared equals, I'm going to just multiply all this. That's a 12c minus 20. And then, of course, I'm going to move everything this way so that I can factor it. C squared minus 12c plus 20 equals 0. 20. 2 and 10. Minus 2 minus 10. So we get c equals 2 and 10. Both positive, so we're good. We don't have to worry. We're going to have positive there, so we keep them both.